Hello Narayana students, greetings of the day. Today we are going to discuss about real numbers. Observe the real number chart. It is natural numbers and zero together whole numbers. Whole numbers and negative numbers are integers. Integers and fractions are together rational numbers. Rational numbers and irrational numbers are real numbers. So the first concept in this chapter, fundamental theorem of arithmetic. As you know, every composite number can be expressed as the product of primes, and this prime factorization is unique apart from the order in which the prime factors occur. So this proof at first was given by Carl Friedrich Gauss, one of the mathematicians who referred as Prince of Mathematicians, and is considered one of the three greatest mathematicians of all time, along with Archimedes and Newton. He has made fundamental contributions to both mathematicians and science. So let us check HCF and LCM of two numbers. As you know, product of HCF and LCM is equal to product of numbers. It is applicable only when the numbers are 2. It is not applicable, need not applicable if it is more than for 2 numbers. If it is positive numbers, generally HCF is the factor of LCM. So observe the given numbers as the product of prime factors. So if you see 140 can be 270 is 335 is 5 7s are. So 2 times, 5 1 time, 7 1 time. Like that we can express as the product of primes. So like that we can observe the remaining all questions in such a way. And if you see, find the LCM and HCF of the following pairs and verify that LCM into HCF is equal to product of the numbers or not. If you see, what is the head? Prime factorization of 26, 2 into 13. 91, 7 into 13. What is HCF? 13. What is LCM? 182. So calculate the product of LCM and HCF, 2366. What is the calculate the product of numbers? 26 into 91, 2366. From that you can conclude LCM into HCF is product of numbers. Similarly, the other questions also in such a way. And also find the LCM and HCF of the following numbers by applying prime factorization method. So this is the prime factorization of 12, 15, 21. Then as 3 is the one of the common factor with the smallest power, so HCF is 3. So remaining 2 square, 3 power 1, 5 power 1, 7 power 1 are greatest powers of prime factors up to 3, 5. So LCM is their product 420. Similarly, the other questions also in such a way. And also given that HCF is 9, LCM is this, then find the LCM. So as you know, LCM is product of numbers by HCF. From that we can get LCM is 22338. Check 6 power n can end with. See whether 6 power n can end with 6 the digit 0. No, because 6 raised any number of times, the unit digit is always 6 only. If any number end with digit 0, then the number product then the factors in the product factors in the given factors of the given number must be 2 and 5. Then only it is ending with 0. Explain why it is these two are composite numbers. If you see, the total simplification is possible to express as the product of primes. So by fundamental theorem of arithmetic, you can say it is a composite number. Like that you are going to conclude. And the circular path around a sports field is there. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So they has to calculate LCM of the given number so that after 36 minutes they will get it. And see how to prove root 5 is a rational number. This is 8 mark question, children. So 100% there will be a chance of 8 mark question for public examinations, 100%. So on this same model, so let us assume that root 5 is rational. That means by the definition of rational number, let Root 5 is a by b, where a, b are integers. So squaring on both sides, then it is then by b square into b square. So 5 into b square means it is multiple of 5. So a square is divisible by 5. That means 5 divides a square. So from the theorem, if p divides a square, then p is divides a when p is a prime. So 5 is a prime. So 5 divides a square means 5 divides a. From that, let a is equal to 5 into c, where c is some integer. So substitute a is equal to 5c in the identity 1, so that you are getting b square is equal to multiple of 5. So b square is 5 divides b, since 5 divides b square, as 5 is a prime number. From 2 and 3, you can conclude that 5 is a common factor of a comma b, but a and b are not co-primes in this regard, so it is contradiction. So our assumption is false. Therefore, root 5 is irrational number. Similarly, you can assume that this is not irrational, means it is rational. Then by the definition of rational number, you are taking, and after that transpose plus 3 to right side, go to LCM. Then it is p by q form, it is irrational number form. A number irrational never be equal to rational, so it is contradicts the given. So our assumption is false. Therefore 3 plus 2 root 5 is irrational. It is true, like that. See, by the same process we are getting. Let 1 by root 2 is equal to a by b by the definition of rational number. So root 2 by 1 is equal to taking reciprocal b by a. So root 2 is equal to b by a. A rational never be equal to irrational. So our assumption is false. Therefore the given one is irrational, like that. Next, same model, same process we are getting into 7 by 7. So it is rational, p by q form, it is irrational. Both are never be equal. Therefore, our assumption is false. Therefore, 7 root 5 is irrational. Like that we are getting. Similarly, next question also in such a way. Here, irrational never be equal to rational. So, by taking the same information, you are going to conclude 6 plus root 2 is irrational. So, this is the information for this chapter. So, wishing you all the best. Thank you.